highlight a couple things here. So we're talking about, first of all, identifying linear functions and their graphs. I'm splitting this lesson up into two. So we're going to get a little portion of it today and then the rest of it tomorrow. And hopefully you can get a lot of your homework done during this period because I know today is Halloween. So might want to enjoy that. But unfortunately, the last class, they're like, Mr. A, you're giving us homework. It's Halloween. I'm like, yeah, but I want to get through it. I want to give you your homework. When it was time for homework, do you think they were all focused on their homework, doing what they're supposed to? No, they were acting or telling me that they didn't want homework, but acting like it didn't matter because they weren't even working on it. So you guys, I hope, can show me differently and hopefully get stuff done. Have a better night tonight. Okay, we're talking about a linear function. Okay, we've already looked at what a function is. Can anyone tell me what a function is? It's a special type relation. It's a special type of relation. And remember, what are 4 ways you can show a relation? A rule, a table, a mapping, or a graph. Guess which ones we're going to focus on? Graphs. And today we're going to look at the rule a little bit more and a table. So the mapping we're going to kind of push aside for now. But we're going to look at a function, a special type of relation. Do you remember what's so special about that relation? Where each
x value has exactly one y.
Good. Each x value has exactly one y value. Okay? Can you guys identify that on these relations? You guys think you could do it? If I gave you ordered pairs or a table or a graph, you could figure that out? Well, we're going to figure it out in just a moment. Ma'am?
Did we do that yesterday?
We did that last chapter. Yeah. We did that yesterday in our quiz, yes. Yep, so hopefully this is not like, wait, what are we doing? Okay, and then some of you might be questioning, what is a non-vertical line? Okay, first of all, it's a line. Can you picture a line in your head?
Yeah.
Okay, it's a line. It goes opposite ways infinitely. But what does it mean by non-vertical? Okay, so you gave me an example like that, something like that?
Straight up and down.
Okay, it can be any line that is not like this. What kind of line is this right here? Vertical. So it could be any line like this. Can it be like that?
Yeah.
Can it be like that?
No. Yeah. Because
This is horizontal, and horizontals are non-vertical. Can it be like this?
yes.
Can it be like that?
Yes.
Okay. And there are many representations
Like this.
of that. So that wouldn't be a line anymore. And that's actually an absolute value graph, which we're not dealing with yet. But anyway, non-vertical line. It can be any type of line that is not vertical. Okay, and then this note down here, this is the key to today's lesson right here. Has a constant rate of change. Does anyone know what constant means?
It's continuous.
Yeah, continuous, the same throughout a period of time. So constant. What does it mean by rate? Rate. What's a rate? Can I give you an example of a rate? Miles per hour. Miles per gallon. Students per classroom.
Measurement plus another unit of measurement.
Ooh, close. Not plus.
Minutes per second. Per second.
Okay,
One type of unit of measurement and then a different type.
Absolutely.
that are being compared. That's all it is. Miles compared to gallons. How many miles can you get for 1 gallon? How many miles can you get for 10 gallons? How many students can you get in 1 room? How many students can you get in 10 rooms? Those are all comparisons of numbers. So, have we dealt with rates before? Have we dealt with comparisons of numbers? Have we dealt with constant comparisons of numbers? Like, I'm going 20 miles per hour on this road. And I'm going 20 miles per hour on this road. Mr. A, we have a constant rate of change, of change. That's actually a key word in math and science. Dun, dun, dun. Welcome to science class. Okay, it's actually cool. Mr. Hubbard and I, we were talking a couple days ago, I think. He came and he's like, oh, so what are you guys going over? I'm like, blah, blah, blah. Oh, we're going over blah, blah, blah. Really? Wait, how are you able to talk about math? That's science. And how can I talk about science if that's math? If that's science. See, I'm getting all mixed up here. Do the two disciplines ever interact?
Yes.
Okay, ready? Does math ever interact with English?
Yes.
History?
No.
Oh, of course not. Come on, guys. That's a stretch if you say it does. It does, and naturally so. How do I know it? What? Did I write any numbers up here?
Yeah. 5 and 1.
Okay, 5, 1. Sorry, yeah. Okay. Did I write anything else after that?
No.
What did I write? A bunch of?
Letters.
Yeah. Who's that related to? English. Imagine that. History. We're going to talk about that too. Yeah, dates. Actually, something even better. Okay, what I want you guys to do is copy this table right here. And we're going to look at a constant rate of change, non-vertical lines, and functions. But we're going to review a little bit. So get this table down. First of all, is this table a relation? Relation. Is it a relation? Yes, it is a relation. It's a set of ordered pairs. Is it a function? Because every x value has only one y value. And that's true. It's a function. I'm not asking if it's a relation anymore. I'm not asking if it's a function even anymore. I'm asking, is it a linear function? You're like, maybe, I don't know. I could graph it out and you can see it very clearly. It's linear or it's not linear. But there are other ways to figure it out, and this is what we're going to pull out from last chapter. In fact, as I was prepping up this lesson, this is really what I do sometimes. I'm looking at it, and I'm like, wait, we talked about that. I think, Jack, didn't we talk about this already? You asked that in class. Was it Jack or Bella? I don't know. But someone said, didn't we do this already? Didn't we talk about this? I'm like, wait, I guess we kind of did. But as I'm prepping up lessons, I'm like, whoa, we did this. We did this last week, and then we did that we did it last year. So we did this a couple months ago. Here's what we're going to do. I have a set of numbers here, and I have another set of numbers here, and they're related. I hope you guys can see it. But is there a constant rate of change? And you're like, what? I want us to pull back sequences. Do you guys remember arithmetic sequences? How do you find if something's an arithmetic sequence or not? How do you do that? Arithmetic sequence. Arithmetic. You subtract, right? So this is what I want you guys to do. We're going to look at the y values. We're going to pretend this is one sequence. Well, pretend is kind of a stretch. It is a sequence, but what kind? So the y's, I'm just going to look at the y's, okay? We're going to just do a few problems. Shouldn't I do 2 minus 5? 2 minus 5. What does that give me? Negative 3. So that's a difference, right? That's a difference. Okay, but then I'm going to do negative 1 minus 2, right? I'm going to subtract these two. What do I get? Negative 3. What in the world? Wait, is that a common difference? Have we looked at common differences before? Okay, but that could be coincidental. What about negative 4 minus negative 1? Uh-oh. We have a common difference. What kind of sequence is this range? What kind of sequence is this? Arithmetic. It is. It really is. So we would say you have a constant. Okay, constant can be almost like common. That has that idea. Constant rate of change. Are you changing by the same amount each time? Yeah. So the y's have a constant rate of change. What about those x's? So let's look at the x column here, right? So we're going to do, can someone tell me the first one I do to figure out if it has a common difference? Negative 2 minus negative 4. And does anyone know what that would get me? Good, positive 2. What's the second problem I would do? Sophie? 0 minus negative 2. And what would that give me? 2. Whoa. Okay, and then what's the third one? Just to try it out again. 2 minus 0 would give me 2. Do we have a common difference? Yeah. Is this column a sequence as well? What kind of sequence? Arithmetic. And that, if it's arithmetic, or even geometric, but we're not looking at those today. Sorry, who asked? Bella?
Did you do the key change thing?
Yeah, I'm doing, it was negative 4, sorry, minus negative 4, stay, change, opposite. Yeah, I did stay, change, opposite. So it's negative 2 minus negative 4.
Where's the second one? I don't understand that one.
This one?
Yeah.
It's 0 minus negative 2.
Negative.
0 minus negative 2, but then plus plus. That's great. Yeah, because I worked it out already. Callie?
I looked at it now.
Okay. Yeah, if you guys have questions, please ask. Okay. Do we have two constant rates of changes for the x values and the y values? You know what that means? This is not only a function, it is a linear function. It has to be a linear function. By the way, does anyone know what a linear function is? It is a function whose graph is a non-vertical line. So could it be this? Could this be the graph? No, because it's linear. And linear means it's non-vertical. Could it be this, possibly? This? 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 Wow, that's like a dance. Okay, anyway, it's a linear function. You know how else you can test it? If it's a linear function or not? Here's a cool way. Can't you just graph it? And can't you see if it's a line or not? I mean, can you do that? Okay, I'm going to graph it, just sketch it out real quick, just so you can see. Okay, I guess it is a line. Someone give me the first ordered pair. Negative 4, 5. And I'm sketching here. Next one.
Negative 2.
0, 1. 0, negative 1.
0, negative 1.
2, negative 4.
2, negative 4. 4, negative 7. Now, sketching it, does it look like, because it's a sketch, you think they could line up? Okay, they do line up, and it is a linear function. You could do it by graphing as well. Okay? Mr. A, can we do it by graphing? Yes, you can. How do you want it, Mr. A? Which way do you think we spent the most time? This way. I need you to figure out this way. Okay. Speaking of change. Speaking of constant rate of change, which is, I think this is cool. This is a triangle, but this is a Greek letter delta. Have you ever heard of delta as a letter?
Yes.
Kappa, delta, like whatever, like sorority or...
Delta Airlines.
Oh, delta. Yeah, delta. It has a triangle. Why triangle for delta? That's kind of weird, right? This actually comes from thousands of years ago. Like this symbol, this triangle symbol is actually thousands of years ago. Wait, that sounds a lot like history. Here's a history lesson. Where did it come from? It comes from the Greeks. Where did the Greeks get it from? They got it from the country of Egypt, or I guess I should say the Empire of Egypt. Let's say 1500 BC, 2000 BC. Was Egypt a major world power? It was. Joseph's time, Pharaoh had control of all the people in Egypt, and they were conquering people. But here's how we get this symbol. You know, Egypt is right by the Mediterranean Sea. What's the major river in Egypt?
Nile.
And actually, it's kind of more like that. Okay, the Nile River. Yep. And you know the Nile River, when it meets the Mediterranean Sea, it makes a triangle. It makes a delta. Have you ever heard of the delta? Like, it's the Nile Delta. So this is the shape of that. And guess what? In its honor, we get that symbol delta with the Greeks that came, I'm guessing like a few hundred years after that. So does that symbol, by the way, is it just randomly picked? Do we just randomly throw out symbols out there? I used to think we did. I'm like, yeah, that's pretty weird. Why don't they just write the word change and then in? Because these symbols right here have backgrounds, they have history, and they're very useful unless you just like writing everything out. Okay, so how do I read this out? I read it as change in y. That's how I read it. Change in y. So how do you think I'd read the denominator here? Yes, ma'am? Change in x. Change in x and change in y. That's weird. Like, who talks that way? We talk like that a lot. What is it now? Fall back. Have we changed our time recently? No, but we will, right? Fall back. Is this weekend? Oh my.
They were going to make it.
Yeah, fall back. Time goes back.
I don't want more sleep.
Did we change time?
No.
Wake up like 7 o'clock in the morning.
You changed how far back? 1 hour, right? You take your hour. If it changes, let's say it changes at 2 a.m. I don't know. It's like a specific time. 2 a.m. And it's supposed to change. What happens? You subtract 1 and you get 1 a.m. So now it's 1 a.m. for us. And by the way, time doesn't change in space. We just use it for daylight savings and all that. But what did you do to get that time change? You subtracted 1, right? You know how you figure out the change in y? We've dealt with this before, but we haven't looked at it this way. It's y sub 2, remember the subs, minus y sub 1. I heard those gasps.
No!
Yes, it's back. Oh. Okay. X sub 2 minus x sub 1. And I say that in a kind way because you're going to use this concept. I'm not calling it what it is yet until tomorrow. You're going to use it a lot. Either you get better at this year, or you stay stagnant, or you decline in this concept. So hopefully you're not going to be stagnant. Hopefully you're not going to decline, but hopefully you get, okay, it's not that bad. Can I give you an example? I see geometry students every week because I help tutor them. And I remember these, and there are many of them, but I remember we went over this and they hated it. Like, it's common to hate. And then we're reviewing it, and they're just doing it. They're not asking me a question, they're just doing it. I'm like, I thought you guys hated this. Yeah. And they just did it. I'm like, oh wow, you guys seem pretty good at it. Yeah, it's easy. Okay. You know what it took to get easier?
High school.
Yeah, high school practice. Yeah. You guys are in high school, by the way. Do you know that? Okay.
High school class.
Oh, sorry, Parker. Surprise. Okay. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What operation is going on there? Subtraction. Okay. And then you could say division after that, but subtraction here. Okay. Do you guys notice something here? It's the second minus the first. The second minus the first. We've been doing this now, and you guys didn't even know it, maybe. You do 2 minus 5, not 5 minus 2. Because you start messing yourself up. We did that last year many times, actually, which is kind of cool. What was the change in y over the change in x in our previous problem? What was that constant rate of change for the y? -3. What was the constant rate of change for the x values? +2. Guess what the slope was? -3/2. We're going to talk about that more tomorrow. Today we're going to kind of keep it simple. We're just seeing if they're linear or not. Guys, I know it's late in the day. I know it's actually kind of warm in here. I know, math may not be your favorite subject, but there's got to be something in you, hopefully, I really hope, I can't force it, that says, I think that's kind of cool that it all comes together somehow. Is that anyone's thought, like things come together? Some like little things like this from last year, subtracting, showing the slope. If it doesn't, that's okay. But if it does, that's awesome because you're starting to understand it. You're starting to, now I get it more, and hopefully you can do it better. Okay, let's move on. Let's make this next table here. My question here is this a linear function? So I'm just going to ask, is it linear? Is this a linear function? All right, that's a question I need to answer. Yes.
Would we do the y first?
You could do the y first and then the yx, or the x second, or you could do the x first.
Since it's y sub 2 minus y sub 1, is it easier to do the y first?
I like dealing with y first, and it's
1 minus -6.
So here, I'm going to do this, right? I'm going to show two columns, the change in y, and I'm going to work it out. So you said what? 1 minus -6? What is that? Yeah, state change opposite, you get 7. What's 0 minus 1? -1. What's 1 minus 0? 1. Oh, 1 minus 0 is 1. And then what's 16 minus 1? 15. Do I have a constant rate of change? No, I don't. And what I do for my work is I just put an X. It's not a constant rate of change. Let's look at the X. Yeah, I want to see here. Okay, X is, what would I do first? -1 minus -2. So stay, change, opposite. I think I just get 1, right? -1 plus 2. All right, and then I do 0 minus -1. Ooh. Oh. Then I'll try 1 minus 0. 1. Then I'll try 2 minus 1. 1. Do I have a constant rate of change for the X?
Yes.
So I put a check. That means it has a constant rate of change. Is this a linear function?
No.
No. So we would put here, your final answer would be not a linear function.
The triangle was like shaded. Was that mean something different? That little delta thing?
The delta?
Like, it means like something else.
I can't think of anything. It might. Yeah, I can't think of anything right now. I can look it up because now I'm curious.
I remember, I think it was like a lesson back. He said there's going to be like 3 deep in linear function. Could we have 3 columns like x, y, z and still have a linear function?
That's when you get a third dimension, you're getting the z axis. We're not doing that this year. Yeah, that's Algebra 2. It's fun, but it's hard to graph unless you could do 3D, which some of you can and I cannot. But yeah, we're not doing that right now, Sophie. Question here is though, why is it not linear? Because the change in y and the change in x are not both constant rates of change. They got to be both. So if one of them is and the other one is not a linear function. Okay, just to visualize it, guys, can someone give me those ordered pairs one at a time? Okay, hold on. Sorry, what's the first one?
-2, -6.
-2, -6. All right.
-1, 1.
-1, 1. Okay. 0, 1, 1. 2, 16. Oh, 16. Okay. Is that going to be linear?
No.
Yeah, you're like, how did these? It's not linear. It's not a line. You can't connect them all with one line.
Well, they actually are all lines and segments.
Okay, yeah. If you take them individually, they might be segments, but they're not a line. They don't keep going that direction. So that's not linear, even if you look at.
They do because the line's infinite no matter what. Because all the points on that graph don't.
This is actually, sorry. This is a special graph, and it's actually, sorry, I didn't look at it enough. It is a graph. It's a cubic function graph. It's when x to the third power equals y. So it has a special little, like, I don't know how you describe it, roller coaster feel. Like it goes down, comes back. That is a function because does it pass the vertical line test? Yeah, but it's not linear. So we just answer that question. Okay. All right, let's do another one here. The question is f of x equals x squared minus 3? Is that, yeah, that's a great question. Is that a linear function? So maybe we have to answer a few pre-questions before we can get to the real question. What is f of x?
Oh, is that x to the second?
Can it just be 1?
So there, I think I'm getting a couple ideas. Could x be 1? Yes. Well, but what does f of x stand for? Do you guys remember that? It means y. Because what kind of notation is this? Functional notation. So before I even answer this question, is it a function? Automatically has to be because it's written in functional notation. When you have this f of x, g of x, h of x, it's a function. But what am I trying to answer? Is it linear? So it's not just is a function. Of course it is. Is it linear? Did they give me a table? No. Can you figure out a table? Yeah. 1, 2, 3, 4, 5. Okay, you have 2 or 3 problems on your homework with this. 2 or 3. You can do it. I know. But yeah, that's what I heard.
That hurts my brain yesterday.
So does working out. Hurts my body.
But this hurts my brain.
That hurts my body.
It's more than my body.
Oh, good. It shouldn't hurt your body too much because you're just doing that. But yeah, I get you. Do hard things hurt?
No.
Sometimes they do. Soccer team, you have a hard practice, you're sore the next day. Basketball team, volleyball teams, whatever sport you play, even when cross country, even when you play an instrument, if you're practicing a lot, it hurts sometimes. It hurts your head. You're like, oh my goodness, really, we got to do this again? But does it have positive outcomes? It should. Yeah, it should. And it will. Oh my. All right, anyway. What do you think you need to do here, guys?
1, 2, 3, 4, 5, 6, 7.
Just pick some numbers, but guys, you need to pick 2 negatives, 2 positives, and a special number, 0. And guys, if you want to pick -2, -1, 0, 1, 2, that's fine. But does anyone remember, are those always the best numbers to pick?
No.
Why not? Give me just one scenario where it wouldn't work. It's not so nice, Josh.
If you had a decimal point.
Ooh, decimal point, yeah. Or a fraction. Yeah, if you had a fraction like 1/2, what would you pick then?
1/2.
I'd pick numbers that relate to the denominator 2. So I'd pick 2, 4, 6. Any of those numbers would make it easier. These would be okay. These would not be so okay. But anyway, easy one here. Okay, this is what you need to do. You need to find out if x equals -2, what does y equal? You're like, there's no y up here. What did we say f of x equals?
Y.
Okay, so that's what I'm trying to figure out. So this is what I do. F of -2 is equal to -2 squared minus 3. Do you guys remember this on your test? Yeah. You're like, wait, no, I didn't have to do this. You did. And so we did go over it. So how do you figure it out? All you have to do is simplify. What's -2 squared? 4. What's 4 minus 3? 1. So if x is -2, what does y equal? 1. Okay. Then I do it with -1. You're like, Mr. A, this takes a long time. Sorry, I don't know what to say. Like, some problems take longer than others. What does y equal when x equals -1?
What's -1 to the second?
Yeah, what's -1 times -1?
1.
1. 1 minus 3? -2. Get me the other values, please. Oh, some of you are quicker than others. You read my mind. Imagine that. Sarah, if x equals 0, what does y equal?
If x equals 0, y equals -3.
Annie, if x equals 1, what does y equal? That's okay.
X equals -2.
-2. And if x equals 2, Cole, what does y equal? 1. Ooh. Remember how I said it has to be a function? It doesn't look like a function to me. Or is it?
It is because there's not more than one x value showing the y value.
Say that again?
There's not more than one x value that has a y value. Wait. No.
I think I know what you mean. There's no x value that has more than one y value. So like, what does -2 give off? 1. What does +2? Wait, but they give off the same thing. That doesn't matter. Does each domain value give off only one y value or range value? Yeah, so it's a function. And we proved it even though we didn't have to. Okay, that's your first step. And guys, you have 2 of these. I'm pretty sure it's 2. Is there a constant rate of change? So what I do here is I look at the y values. How do I find a rate of change or a common difference?
-2 minus 1.
What does that give me? 3. Then I do -3 minus -2. What does that give me? I think I heard, yeah, -1. Let's do it one more time because I could have messed up. -2 minus -3. Yeah, guys, we're doing this and then doing that. State change opposite. 1. Do I have a constant rate of change? I do not. Is that linear?
No.
Can't be linear. Not linear. I'll even let you write that down if you want. Yeah, the book is going to say in the instructions, determine if it's a linear function or not. Explain why or why not. You know what my explanation is? It's right here. That's my explanation. So you can't just say function, not a function, because you didn't explain anything to me. You need to show me why it's not a function, and then that's an explanation. So that's all it means. Show your work is what they're saying. Okay, you guys good on that?
Yeah.
Ma'am?
Will X always be linear and then like Y can either be linear or not linear?
It's possible, but sometimes they give you the chart, they give you the table, and so it might not be. X might not be. But if we make it, almost always we can make it linear, or we can make it a constant rate of change, but it won't be on the Y. Yep. Oh. This last one we'll do together.
What? It's
Huh?
not that it's vertical, right?
I don't know.
Or is it
It's a good question. Great question.
Yeah, but what? It's a trick question.
Is it? I don't do that. Wait, no, I do those. I do those a lot. Okay. I don't know. Maybe. Sometimes. Okay. Here's what you do, guys, and it shouldn't take you very long. In this case, you're going to make a quick table, and you're going to find out the work is very, I hope, very easy. 1, 2, 3, 4, 5, 6. 2 columns. X, Y. What does Y equal? 7. In fact, Y always equals 7, no matter what. Wait, where's X?
I don't know.
You have to figure it out.
You pick your X values, but they don't tell you anything about X. So we'll go -2, -1, 0, 1, 2. What does Y always equal, though? 7, 7, 7, 7, 7.
7, 7, 7.
Do I have a constant rate of change for the Y value?
Yes.
So check. Do I have a constant rate of change for the X values? Yes. Is that a linear function?
Yes.
So say it's a linear function. There you go. Nope, don't like that because some of you were saying it's a vertical. No, it's a horizontal. No, I don't know what it is. Give me those ordered pairs, Callie, one at a time. -2.
-2, -7.
Sorry, -2.
7.
Mm-hmm.
-1, 7. 0, 7. 1, 7. 2, 7.
What kind of line is that?
Horizontal.
But I thought it has to be a non-vertical line.
But it is
Okay. Is it a line? Is it non-vertical? So is it not this? Mm-hmm. Does it pass the vertical line test? Yes. So it's linear. Imagine that. Begin. Goodbye, Swivel. You guys did well.